Hello, everyone. My name is Farzad Jalaei from National Research Council Canada. Welcome to the webinar on revolutions in renewable energy in 21st century. I'm going to present one of our recent projects at National Research Council regarding the exploring the effects that a non-stationary climate and dynamic electricity grid mix have on whole building life cycle assessment with a multi-city comparison. What I'm going to present is like introducing the problem statement of this research along with the research objectives, methods, and I'm going to show you some results along with the discussions that happened to interpret the results and the concluding remarks as well. Before starting the presentation, the outcome of this research project is recently published in the Journal of Sustainable Cities and Society with the link that I provided above of this slide. So if you are interested in getting into more details about this project and how we develop these different modules in this project, so you can reach out to the this journal with the link that I provided you and read the whole paper. Regarding the problem statement, most whole building LCA related works mostly assume the static grid mix and the static climate based on the present conditions. But as you may know, the building that is designing currently is going to stay and operate for, let's say, at least 60 years from now. So the in reality, the condition of the weather and also the grid mix will change significantly over the service life of the building. So it's technically very challenging and time-consuming issue to consider a non-stationary climate when undertaking the high-resolution operational energy simulation for the buildings, and also challenging to consider the future dynamic grid mix to consider such dynamic life cycle inventory in the life cycle assessment type studies. So this research objective is to analyze and better understand the effects that the non-stationary climate and prospective electricity grid mix have on whole building life cycle assessment projects with considering the regions with different climate and grid mix in Canadian cities. And we did the contrast with the differences between whole building life cycle assessment results when considering such dynamic conditions when compared to typical current static condition. So we also develop a highly automated workflow and framework to better enable the widespread application of dynamic whole building LCA simulations. This is the whole overview of the project methodology. As you can see, this project is conducted at the conceptual stage. So the main contribution is integrating the building information modeling concept with life cycle assessment to assist the designers choose the materials and components that have lower environmental impacts. So this will also promote the sustainable development practices by incorporating environmental improvement approaches within the project. So as you can see, we have the 3D model as a case study in building information modeling environment. So we did the quantity takeoff extraction or bill of material extraction automatically and input it into the developed BIM-based plugin to automatically map with the lifecycle inventory data, which we use the co-invent, and like it is going to be done in different stages of the project lifecycle to calculate the embodied lifecycle impacts of building. The operational lifecycle impacts is also going to be done by like calculating and measuring the local future weather data by combining the observational climate data from like stations that is close to the case study locations, along with the Canadian Regional Climate Model large ensemble climate database. So to make it very simple, I'm going to show you here, which is like, this is two pathways that we are going to follow in this research, which we have the BIM model. We are going to measure the embodied impact by using our developed BIM plugin to connect or integrate the lifecycle inventory into the bill of material coming from the design and put it in the OpenLCA to calculate and measure the embodied impacts. We use our studio and like in the Energy Plus by developing the climate and grid mix files to measure the operational impacts and define some scenarios for different locations based on combination of static and dynamic climate and grid mixes. So to compare it in different regions with different type of climates. So about the data preparation, the climate data preparation, we saw like the previous work of one of our co-authors of this research is greatly matched with our need, which is which is like high quality resolution climate data, and which is the long-term regional climate simulation from Canadian Regional Climate Model, which is attained by downscaling global climate simulations at 2.8 degree from the Canadian Earth System model to 0.44 degree over North American domain. So we use the RCP 8.5 scenario, which refers to the concentration of carbon that delivers global warming at the average of 8.5 watts per square meter across the planet. And also we use the large ensemble of 15 members with different sets of initial conditions and cloud physics parameterizations were considered to account for internal variability. So the large ensemble was biased corrected to local weather station across 11 Canadian cities in our colleagues' work, Gower, in 2019, which we used the 3 cities information in our project. So time series climate data from 2020 to 2080, RCP 8.5 were compiled at hourly resolution, and Energy Plus EEPW files auto-generated using an R script. So the library of E plus R provides us a rich toolkit for using the Energy Plus directed in R, which enables programmatic navigation, modification of Energy Plus models, and makes it like less painful to do parametric simulation and analysis. So about the projected regional grid mixes, as you can see at the right side of the slides, the depicted prospective regional or provincial grid mixes for the cities considered for three regions in Canada: Alberta, British Columbia, and Ontario, based on the recent study or simulation from the National Energy Board of Canada, based on annual temporal resolution. And we generated the technology which is linked to the best available eco-invent activities for that grid mixes. And but it is almost like calculated by 2040 for our study. But beyond 2040, the grid mix share was based on some simplified assumptions regarding renewables, penetration, and fossils phase out. So the scenarios considered for is we have a case study, which is a clinic building or clinic office building. It is hypothetically assumed to be in 3 Canadian cities, the same model in 3 Canadian cities. We assume 2 heating sources, natural gas boiler and electric source or electric baseboard, let's say, for heating. And 4 scenarios considering the climate and grid combination, like static climate and grid, static climate, dynamic grid, dynamic climate, static grid mix, and dynamic climate and grid mix. So the total scenarios are 24, as you can see here. And the right-hand side is the details related to the case building. As you can see, like it's almost like 1,000 square meter total building area with like almost like 781 square meter of net condition building. And there are some construction information or the heating and cooling systems that is assumed for electricity plus gas scenario or electricity only scenario here. So the energy plus simulations, we almost like ran around 5,400 simulation years performed for 3 cities, 2 building design for 60 years, along with the 15 climate members. So variety of these climate members are shown in dotted lines here. And also you can see the natural gas heating design configuration is also like illustrated. So the results show that a changing climate tends to reduce overall impact over time for most cases, and it's like the relative reduction is more substantial in regions with cleaner grids and natural gas heating. A changing grid mix enables substantial reductions in impact and is more influential than like the changing climate, just the only changing climate scenarios. The impacts are very sensitive to what the projected and actual grid mix will be, and a changing climate in long term can bring significant reduction in overall energy requirements due to the less heating and which is related to the colder climate regions. Regarding calculation of embodied impacts, as you can see, these are different snapshots of the developed plugin in BIM environment, building information modeling environment. I will walk you through some large images here, which is like the general parameters of the plugin, which is like directly opens up in the BIM environment. You can like specify the life expectancy along with the type of structure and usage of the building, and you can automatically connect your plugin to the Google Map application programming interface to locate the project. And as you can see, after that, in the plugin, the bill of material is automatically extracted from BIM model and shown up in the plugin. So we use also like color coding to navigate what items are mapped, or what items is going to be mapped, or what items or bill of materials are not mapped yet. So the user can easily see what is extracted and what relevant processes in the lifecycle inventory is available to be mapped with that extracted item from design. So by doing so, in each life cycle of the project, like production, and the same story in the construction, like the transportation. For the transportation, for example, if you specify the location of the supplier of that material, the Google Map can automatically calculate the distance and attach it to the type of transportation related process in the construction stage. So this process is going to be done by the end of life stage, and by selecting the right life cycle impact method, the JSON type file is extracted from the BIM plugin, which can be imported into the OpenLCA. So in the imported file, you can see all the processes and the product system are mapped to each other, which directly directs the user to the life cycle impact assessment results. So the embodied environmental impact results related to the climate change, which is called global warming potential, is shown here. As expected, the production of building components has the more share of the GWP impacts in kilograms CO2 equivalent per square meter, and also like the replacement of building components has the stays in the second stage. In terms of activity-specific life cycle impact assessment results, pre-calculated Monte Carlo simulations, around like 5,000 runs, were utilized to enable uncertainty analysis to evaluate the robustness of the impact results. So we took the mean number from these uncertainty analysis results to include it in our final assessment. So as you can see here, this is the results for the mean results for the total impacts for different cities and different grid climate scenarios. As the results also like illustrate the importance of dynamic perspectives in environmental impact assessment of building projects. I can say like the first finding of the contribution study here is that the use stage, the operational impacts, remains the significant contributor here, but its share depends greatly on the evolution of grid mix and the grid mix of the region itself. A second key finding here is like if you look at the percentage contribution of the embodied and the operational impacts, the static grid mix scenarios, I mean the scenario A and C, showed like very similar results, and the dynamic grid mix scenarios also had similar embodied impact contribution for each city. So even though the climate change effect is considerable, this effect is small in comparison with the grid mix evolution scenarios in reducing the GWP impacts. And the results also like identified that the electricity-based space and like water heating is still recommended as a climate-friendlier HVAC system for the regions like Ontario and British Columbia, but like Calgary with high percentages of the impact, like GWP impact, is more favorable for the gas heating than the electricity for like the Alberta region. So in the dynamic grid mix scenarios, the embodied and operational impact contribution percentages are nearly equal compared to the climate change scenarios. So comparing all scenarios for all three cities, like scenario D, I mean like the dynamic scenario shows the least GWP impact, which indicates the importance of using both dynamic climate and dynamic grid mix scenario in LCA studies. So the limitations and the future research recommendation here is like the prospective electricity mix scenario were assumed to evolve independent for a changing climate. The regional electricity mix projections were simplified. We only consider the annual average mix and National Energy Board projections only went till 2040, and embodied inputs were also assumed the same for each city scenario. Like in the construction stage, we just consider the machines and transportation. So some other construction type activities plus maintenance activities were not covered in the LCI due to a lack of meaningful data. So our key recommendations is like to address these limitations mentioned and consider applying the framework to a wider area of like building archetypes and like not just consider it for the colder climate, for also like consider it for the moderate or like the tropical regions which might have some significant impact results. And also like we need to explore how operational impact change when a high resolution grid mix model is applied. And also like we are in process of looking to advance our BIM plugin in further integration to make the process of data mapping in full automation way. So yeah, I believe that's it for this presentation. Thank you very much for listening to this presentation. And if you are interested, please like be in touch with me in my email. Like it's farzad.jalai@nrc-cnrc.gc.ca. And if you are interested in reading like more detail about this work, please follow that link and reach out to the Sustainable Cities and Society Journal and read the paper. Thank you very much and have a good day.